Hi, in this video I'm going to walk through a sample with the Syncfusion Big Data Platform running the Spark environment. So I'm just making sure that the local service manager says Hadoop is running. I need to have HBase running, but I'm just going to leave it as is. I'm going to start the Big Data Studio. I already have it set to the Spark tab, and just to point out, at the top left, you see three options basically when running Spark. So the default is to use the Scala shell, and that's the using the Scala programming language to work with Spark. Spark itself is built using Scala, and Spark's natural language can be seen as an extension or a DSL on top of Scala. Spark also offers a Python API, which is full-fledged, and you can work with it using the Python API if you're comfortable with Python. There's also an IPython interface that we support, but that is a subject of a different video, and I'll walk through it in more detail in that. So right now we're going to use the Scala shell first, and then also quickly look at the Python shell. So with the Scala shell, we have multiple samples on the left side. And these samples range from very simple word count, text search, hive select kind of samples, all the way up to machine learning samples that you can work with. The key difference between using Spark and MapReduce is that Spark offers higher level abstractions that are more numerous. So you can do things such as map and reduce, and many other primitives such as filter and reduction by key and so forth. The other thing is Spark is also aims to be much more efficient than MapReduce. It doesn't write a lot of the intermediate data to disk. It tries to keep as much as it can in memory. It uses this abstraction called a resilient distributed data set, and it's primarily going to be held in memory to the extent possible, and tries to work with it in a very efficient manner, making use of available memory as much as possible. And you have control over a lot of those things as well. Okay, so in this case, I'm going to look at a very simple sample to kind of get started. As a word count sample, as with the Hadoop instance, we're going to look at the text of War and Peace, which you may remember if you looked at the earlier sample, is stored under the data folder on HDFS on this cluster. I'm going to switch back to the Spark tab, and you will notice that this is very few lines of code, very little code to do essentially the same as the MapReduce word count job, basically, which is a lot more verbose. So let's walk through each part of it. The first part just points the text file and then loads it. It doesn't actually load it, but it holds a reference to it. Spark is going to do work in a lazy manner. It will only go back and do work when it has to finally produce results. So it's lazy loading the text file and maintaining a reference to it. And then the first part of the transformation is a flat map. So let's leave out the flat for a moment and think about what would happen with the map. So with the map, as it loops through each line of text in War and Peace, each line is passed to this lambda function, and then the line is split on space boundaries. So each word will become its own entity, basically, and you can think of it as yielding a collection of words, one per line in the file, basically. So you will essentially, if this is a map instead of a flat map, then you will get a collection of arrays. You will get one array for each line, basically. I have a little bit of text here to make that clearer. So let's say that these are the three lines of text that we are looping through with the and passing to the first lambda expression, first map. What we would expect to see as output is three arrays. So one for each line, and you will see that each of them contains all the words as part of the array, basically. Now the role of flat map here is to simply flatten this collection of arrays into one large sequence. So you can see that in the next paragraph. I have one array, and all the individual arrays kind of were merged into this one array. And that's really what we need. We don't care about the individual lines. We just want to get one sequence then at the end of that flat map. And that's what it does. So we get a sequence containing all the words that are in the document. And then I have another map which takes each word and then outputs a tuple with the word as the first part or the first record, and then the value 1 as the second record. So going back to my little text file example here, I have, for instance, if this word story appears in the document, it will be output as story and then comma 1, a tuple. It appears twice, there will be another instance of story, comma 1, and so forth, basically. So that's what you will have at the end of the day. And then once you are done with that, then the final operation that runs is a reduction by key. So in this case, the key is the first part of the tuple. So the word is the first part of the tuple, and you have all the values that belong to that particular word. All the values that appear will be passed to the reduction function one by one. So let's again go back and look at my example here. So the first time reduce is called, it will be called with the first two values, 1 and 1, and it will yield a 2 as a response, because this is Scala shorthand for saying the two parameters that are coming in, first parameter plus the second parameter. And then the second time it's called, it will call it with the previous value that was yielded, and then we'll call it with another one, and this will go on till the whole collection is consumed. So you will actually receive the count at the end of this cycle, basically. So finally, this is really what is going to trigger the actual action. So it's going to do a counts dot collect, which means process everything and bring it back to the driver program here, and then I'm just going to loop through the results of the collection and just print it to the console. So let's run this. It will go submit it to the cluster that I have running here, and you can see it run for a few seconds, processing the text now, and it should be back. So the job completed successfully, and there are the results of the counts from War and Peace. Okay, so let me quickly switch to the Python version of the console and show you the Python version of the sample as well. You can see that the shell is switching and starting the Python version of the shell. So the sample looks very similar. It's just the syntax is a little different for Python lambda expressions. You see the keyword lambda, and then but everything else is going to be pretty similar. And in this case, instead of looping through, we are simply saving the output to a file on HDFS, basically, to a folder on HDFS. So hopefully that gives you a quick idea of how to work with Apache Spark from within the Syncfusion Big Data environment. We saw working with the Scala API and the Python API. As always, if you have any questions, please feel free to contact us through the Direct Track support system. Thank you.